Alright guys, welcome back to Yerkit Racing. Today we're going to be making our first attempt at cutting some soft jaws for our timing pointer out of aluminum on our AnoleX 3030 Evo Pro CNC router. So we're not going to waste much time, we're going to jump right into it. If you guys have been following along with the channel, you've definitely seen some stuff that we've tried to cut already. We're still running at this point pretty much the same settings that we've been running. So I know it's going to take a long time for this particular program to run. We have some stuff in the works to try to pick the pace up, so I just want to preface the video by saying that. But anyway guys, we're going to jump right in. Let's see what we can do.
Alright guys, so we're getting ready to cut the soft jaws for our pointer to be able to sit in so we can machine both sides of it. Let's see how it cuts now. This will be 60 inches per minute, 10,000 RPMs, 0.25 millimeter step over, and 0.25 millimeter depth of cut. Okay, so we just finished the soft jaws, and this is the 3D printed timing pointer that we had done to test. Everything fitting up very nice there. Really happy with that. So now we're going to actually move over and we're going to try to actually make one of these. So the first cut here is going to be the model being that orientation, so it'll start cutting, you know, this top area here out first, and then once that's done, we have it set in the computer over here where we can flip this upside down. Then it'll sit in here. We'll put this whole assembly in there. It'll have like a cap around the top that we got to machine off and then face. So anyway, pretty complex part for me. Learned a lot so far and still trying to learn some more, but this stuff is doable guys. It just takes, you know, a lot of research and focus and really paying attention to details and stuff. Once you set the block up in the vise here, I had to model this whole vise in our CAD software because I'm pulling a reference point right here off of this corner of it so that everything stays consistent. So the computer knows, the program knows that every time that this is home, and it knows to calculate the distance from there. That's how we're able to flip the part. In theory, hopefully it'll work out like I think it's going to. But anyway, let's give it a run, see how it goes. Well, that's just stuff. Man, come on, man. Why is it going all the way up there? Do I not have, I must not have enough clearance room still. excruciatingly long process. Still got a little bit of cleanup to do. I'm going to have to come up with a path that'll kind of go all around it just to do a final touch up on this side before we flip it into the soft jaws. Like I said, this part will end up flipping into here. Just want to show y'all something though. Kind of crazy. It was already a long file and it missed it by 2.5 hours, almost exactly 2.5 hours. That is pretty crazy. Not really sure what happened to make it be that much difference between the two. Anyway, we got a big announcement that's going to be coming up pretty soon. Something I'm really happy, excited about. It should pick the pace up a lot. I'm not going to let it out of the bag just yet. We're going to kind of wait another little bit before we say anything, but this definitely needs some improvement on the speed of cutting this part, because we still got to flip it over, mind you. And the other side looks like it's going to take another probably 14.5 hours or 14 hours according to the file, 13.5, something like that. And I mean, if it takes 2 hours plus again, I mean, you're going to be talking about 32, 34 hours to cut one pointer out. Just for this particular design, I mean, it's pretty complex. It's just, the thing is, it's a lot of material to remove. You can kind of see we're milling away a lot of stock here with the 1/8 inch bit, and it just isn't designed to take that kind of material, you know, out. It's more like, I feel like the 1/8 inch stuff is more for finishing work, so to speak. It can cut some stuff, but you don't want to be milling a ton of stock away. So anyway, that's where we're at. It's late, really late at this point, 2:04 in the morning. Started that file, I don't know, roughly 8 o'clock this morning sometime. So definitely glad that it's finished running. I'm gonna go to bed, work on it a little bit more tomorrow, see if we can get the file to do the finishing pass before we actually flip the thing over, and we'll go from there. Alright, we'll catch y'all tomorrow, guys. Alright, so we had to come back and make a couple of finishing passes on top. I needed to make an edit to the file, so rather than run the whole process again, because I had it doing it both at the same time so I wouldn't have to do extra inputs in the computer, rather than do the whole thing again, I made a temporary file and also edited the other file to, you know, match this one, so next time we run it we shouldn't have to do this again. But for now we're just going to run this finishing operation across the top again, and after that we'll kind of see where we are. That's what we're doing now. We've loaded it up in the computer, just gotta get ready to send it over. Alright guys, so that's a whole lot better. The surface finish is really smooth now, so very happy with that. Now though, because I had to cut a little bit more material off, my radius is kind of gone on my edges, unfortunately, but I can make a temporary file just to come back, clean the edges up for this particular one. Like I said, on the next one we won't have to do that, because I ended up having to cut a little bit more off the top of this one just to reface it because it wasn't smooth like I wanted it. But overall, really happy with it. I'm going to go ahead and clean the edges up so that that's all nice, and we'll be good to roll. Alright, we're getting ready to run the tool change here for the ball nose end mill and the contour around it. In hindsight, I know I said I might not end up having to do this on the next one, but actually I'm kind of liking the idea of being able to swap it out and actually run the ball nose. I think it'll give us a little bit better finish profile on it. So we'll see how this turns out, but that might be the way we end up kind of sticking with it. This is a little bit shorter bit too, so should give us a little bit better stability. Maybe not quite as much chatter through it. Alright guys, so there you have it. That extra finishing pass there, man. It really cleaned it up. That ball mill did an amazing job. Just everything is ultra smooth. That's the finish that we were actually looking for. So really happy with that. I'll go ahead and break it out of this thing now. Hopefully we're gonna get ready to flip it and do the other side. Be the first attempt at milling the second side of something. So hopefully it'll all turn out like we're looking for here. Alright, so there you have it. It's definitely a cool looking piece. I mean, really happy with the finish quality on it. Made a little mistake on offsetting the material. You can kind of see we were really close on this one edge, so just have to be mindful of that. I need to use a little bit wider stock going forward, but otherwise really pretty happy with the way that one came out. So for this next operation, we set these blocks back in here. Now we'll take our other piece that we just cut. It'll flip upside down inside of our jaws like such, and then I'll have to line these front faces up with each other. Okay, so I can see one problem already, and I kind of had a thought that this may be an issue, you know, just from a height perspective, but our soft jaws that I've milled down here, there's a gap, and in order for that gap to not be a problem, I really need the pressure from these jaws to be up onto the actual part. So that's going to have to be remedied. The only way I can really do that is to mill these blocks down, you know, to where they're short enough to sit inside of the bottom down there. Kind of wish it hadn't gone that way, but that's where we're at, so I'm going to flip it around, see if I can mill some of that down.
Alright guys, so as you can tell, we ran into a couple of issues with this. We made our jaws out of stock that was too tall, basically is what happened. Used what we had around here, and unfortunately when we go to tighten it down in the fixture, all the pressure, because the vise is not very tall, all the pressure is trying to be underneath the part, and it's basically kind of pinching the bottom and squeezing the part out of the top. It'll clamp it a little bit, but not nearly enough for what we need. As I started running the program, you saw it dug into the part and it started kind of, you know, breaking the clamp, and then all of a sudden it popped it out and through it. So we're gonna have to jump back on the drawing board for that. And for those of you guys that stayed around to the end of the video, I'm gonna give you a sneak peek here of what we got going on. I told you we actually have something in the works to speed this thing up, and I'm really excited to get to it. We've been trying to get all the programming and stuff straight to switch over to this, but what we have is a box back here from AnoleX. They sent it out to us. It is going to be the 1.5 kW. This is the holder for the spindle, but this is the 1.5 kW spindle upgrade. So we'll actually have, I think it's 20,000 or 25,000 RPM capability versus the 10,000 we have now, and a lot more power, and we can step up to the 1/4 inch bits with this one, no problem. So definitely looking forward to that. It should cut all of this time down tremendously. All right, yeah, guys, so that's a quick little preview of what we got coming up on the channel for those of you who stuck around this time. Appreciate y'all again. If you haven't already done so, hit the like button down below. Make sure you subscribe so you can follow along with the updates as we get them. And we'll see you guys on the next one. Thanks and God bless.